All right, this video we are going to look at topic number 3, in which we are just looking for the zeros of functions. So again, the zeros of a function is where it passes through the x-axis. To find the zeros, we set the equation equal to 0 and we solve for x. So remember, we just talked about while working in quadratics that there are 4 different names for the x-intercept. Sometimes they call it zeros, sometimes they call it solutions, sometimes they call it roots, but it all means the same thing. Where does this function cross the x-axis? So on number 15, all it wants to know is where does this function cross the x-axis? And it happens to be right here. And I'm only worried about x, so the 0 or the solution here would be x is 2. Again, 16 crosses here. So x is 1, 2, 3. X equals -3. We're just trying to find the x value. Crosses twice on this one because it's a parabola, so it's going to cross here and here. So this is at -1, and this looks like 1, 2, 3, 4. So I would say that x equals, I'm going to go ahead and put this in braces as a set, -1 and 4. Those are both, you could also say x equals -1 and x equals 4. What if we've been given an equation? F of x equals 2x plus 2. Remember, we are looking for where it crosses the x-intercept, right? Or the x-axis. And when that happens, the y is always 0. Remember, y is the same thing as f of x. So instead of f of x, I'm going to write 0 equals 2x plus 2. And I'm going to solve my equation. So I'm just going to go ahead and subtract 2 from both sides. So -2 equals 2x, staying in balance. This is multiplication. We'll divide both sides by 2, and we would find that our x value is -1. So x equals -1 here. Let's go ahead and look at 19. Same thing. We're just looking for the 0. So instead of f of x, which is a fancy way of saying y, and I know when the function crosses the x-intercept, the y is at 0, so y equals 2/5 x minus 4. Again, two-step equation, so add 4 to both sides. 4 equals 2/5 x. Oh, there's that fraction again. Remember, we're going to multiply by that multiplicative inverse, so we now have, well, 2 over 2 is 1, 5 over 5 is 1, so I know that this is just going to be x, but I have to multiply to the other side as well. So we're going to multiply 5 over 2 times that 4. We can just put that 4 over 1. 5 times 4 is 20, and 2 times 1 is 2. Now I can simplify that. 20 divided by 2 is 10, so I would say that 10 equals x, or we could say that x equals 10. Okay. One more here, f of x equals x squared plus 3x minus 40. Now hopefully you noticed right away that this is no longer linear. That squared there tells me I have a quadratic. We've practiced quadratics, right? So 0 equals x squared plus 3x minus 40. The first thing I notice is that this has a 1 out front, so I'm going to look to see if I can factor this quickly. Is there anything that would multiply to make -40? That would add to 3, and there is 8 and -5, so I'm just going to go ahead and break this up into x plus 8, so positive 3, so x plus 8 and x minus 5, and I know that this all equals 0 still, so this is where I'm going to tee it up. I'm going to set them both equal to 0, so x plus 8 equals 0 and x minus 5 equals 0. Go ahead and solve for both. This would mean that x is -8 and x is 5. I'll set that up using braces. So my solution set here, -8 and 5. So again, quadratics are a little different than linear. Linear, we're just solving an equation, where in quadratics we'll need to factor or use one of our other methods. Let's take a look at a couple more of those here real quick. All right, here number 21, we're going to go and say, okay, so that means 0 equals 2x squared minus 72. First thing I notice is that I have binomial. So that kind of tells me I might be looking for that difference of squares. Know that I always want to start by looking for my GCF. So I have a 2 and a 72. So let's go ahead and pull a 2 to the front and leaves x squared. 72 divided by 2 is 36. So now I have x squared minus 36. Ah, yes, x squared minus 36. That most definitely will break into a difference of squares. So that would be 2 times, this will be x and x, and it'll be a positive and a negative 6. Remember, all of this is still equal to 0, right? That's what we have it set up to. So we're going to go ahead and just tee each one of these up and set each one of our factors equal to 0. So 2 equal to 0. Well, of course, that doesn't happen, so I'm going to cross that off. X plus 6 equals 0. If I solve, that means that x would equal negative 6. And then I have x minus 6 equals 0. If I solve, that would mean that x is positive 6. So in this problem, we could say that our solution set is negative 6 and 6. All right, number 22. Again, I'm looking at a quadratic trinomial. So I'm going to go ahead and think, is there anything I can use that will multiply to 25 and will add to negative 10? Yeah, 5 and 5, right? Negative 5 times negative 5 makes positive 25. And then negative 5 and negative 5 will add to negative 10. So I'm going to go ahead and divide this up. Now I'm going to set each one of my factors equal to 0. So x minus 5 equals 0. And well, x minus 5 equals 0. So since they're the same, I just need to do 1. So that would mean that my solution set here would just be 5. And those are braces. And then in number 23, I have another trinomial. But I also notice I have a 5, a 5, and a 30, so I'm going to go ahead and get the GCF out first. And then I'm going to notice, is there any way I can break down the negative 6? So I'm looking for two factors that multiply to negative 6 and add to, well, the coefficient of the b term here is 1. 3 and 2, right? 3 times, it'd be negative 2. So 3 times negative 2 is negative 6. And 3 minus 2 is 1, so that absolutely does work. So let's go ahead and break this down further. This would be x plus 3 and x minus 2. I can go ahead and say, well, if I want to solve, I'm going to go ahead and tee these up and make sure everybody gets set equal to 0. So 5 equals 0. Well, that's not true, so I'm going to go ahead and cross that off. I have x plus 3 equals 0. Solving for x, so I'd subtract the 3 over. Therefore, x would equal negative 3. And then I have x minus 2 equals 0. I would add the 2 over, so x would equal 2. So my solution set here would be x equals both negative 3 and 2. So this would cross the x-axis twice, once at negative 3 and once at 2. So that's just kind of breaking down, what if I want a 0 or a solution or a root or an x-intercept? The 0 goes in where the y is, and don't forget f of x is another way of writing, the function at x is another way of writing y. These are the same.